Unit 4, Homework 6, column number 3. Okay, number 1, angle A and angle B. So I went ahead and drew this out so we can kind of fill in the missing puzzle pieces here. So we got 45 plus 50, and then we know that a straight line equals 180 degrees. So if you add 45 plus 50 together, you get 95. You can subtract 180 minus 95 and find that will equal 85. So 85 would be angle B. Okay, so since we have angle B and we know what this one is, which is 75 degrees, well, we can do kind of the same process to find the missing angle within the triangle, because 3 angles within the triangle equal 180 degrees. So 85 plus 75 will give you 160. So then 180 minus 160 is 20. Okay, number 2, we're going to do to a similar process to find the inner values of the angles in the triangle. So we have 40 plus 90 plus x plus 57 equals 180 degrees. We must combine like terms. 40 plus 90 plus 57 will give us 187, and we still have that remainder x here, so it's plus x equals 180. We're going to solve for x by subtracting 187 on both sides. Therefore, we're left with x equals negative 7. Okay, number 3, we are going to draw out the milk carton as it's described in the question. So I drew something similar to what I imagined it to be. So V equals big B times the height. Okay, so we have length times width for the area of the base, and then that would be 30 times 10, which is 30 times 10 is 300. 300 times 50 would be 15,000 centimeters cubed. Number 4, we're going to find the circumference and the area of the circle. So if they're giving us the diameter is 8, therefore the radius would be 4. Okay, so we can find the area using our area formula. Pi times 4 squared, which is the radius, and then 4 squared times 4 squared is 16, so 16 times pi is 50.24 feet squared. Alright, our circumference is pi times the diameter. So if our diameter is 8, therefore it would be 3.14 times 8. Okay, so the circumference would equal 25.12 feet. Number 5, it's asking for the they're asking for the volume when they're giving us the surface area. So it's kind of like we're working backwards here when we typically do the surface area of a cube. We know with a cube there are 6 sides. So we can divide this 150 units squared up by 6 to find the area of just the first side, or one of the front sides. Okay, so we realize that when we divide, we get 25 units squared, and this consists of one of the 6 sides of the cube. Okay, so if we know one is, then we can take the square root of 25 to find the length and the width, because that is what a square is taking the length and the width. And since it's a cube, we can take the square root, because 5 times 5 is the dimensions here for the square. Okay, so the length would be 5 and the width would be 5. Okay, so if we have this, then we have enough information to find the volume of the cube. So volume equals big B times the height. So we have our length times width times our height. 5 times 5 times 5 would equal 125 feet cubed. Okay, number 7, we're going to find the area of the shaded region here. So first off, we need to find the area of the whole circle. So that would be 34 times 14, which will give you 476 units squared. And then we need to find the area of the semicircles. Well, the good news is the semicircles are the same size on both sides. So if the diameter here of the circle is 14, then the radius would be 7. And so we're going to represent this half circle as actually a whole circle, because its other half is over here. So it's kind of like putting it back together again to find the area of both circles. Okay, so we found that the radius is 7. So we can plug that into our formula here, which is 7 squared times pi. So 7 squared is 49. 49 times pi will give you 153.86 units squared. And to find just the shaded region, we're going to subtract the area of the rectangle minus the area of the circles. And doing that will give us 322.14 units squared. Number 8, the shape you see, the three-dimensional shape you see is a rectangular, which is because of the bottom base. Pyramid, because it all makes a vertex at the very top, so it's a rectangular pyramid.